Hi, so my name is Saurabh Joshi and I'm a part of Team 4 along with Sahil and Sanjay, and I'll be talking about mobile application review classification, which was our project for knowledge processing technologies. So in knowledge processing technologies, we learned a lot of text processing, text modeling, and text analytical techniques that we try to implement in this real world application, where we model the data based on the user reviews from the Google Play and build a model in such a way that the future reviews can be easily classified, and the development team can get the knowledge based on the user reviews. We know the Android application has a repository in like a Google Play, which provides a platform to the users to write the reviews, and these reviews can be helpful for the development team. They can help the development team in improving the application, and also sometimes the users can catch the bugs while 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 using the application which they write the review of, and that can really help the development team to fix those bugs based on the reviews that are there in the Google Play. So the problem statement that we came up with was that there is lack of mechanism for extracting the required knowledge from the user reviews on Google Play, and that can pose a big problem in front of developers. So even though the user reviews are present in a Google Play, there is no real model that develop that can process those reviews and give development team exact knowledge of where their application is lacking, or which part of their application is really great, or whether there are any bugs and which part they should work on. So that is the problem statement that came up. So the key issues that are faced by the development teams are that there are a lot of reviews. So if it's like a very big application, like say Facebook, they can receive thousands of reviews every day, and there is no mechanism which can analyze that reviews and give proper information. Another problem is that the reviews can be in different languages. They can be in different synthetic structure, so they can be like positive or negative. You cannot know whether that review is positive or negative, like mixed reviews. There can be they can be using short forms or special symbols, and analyzing those kinds of reviews can be tricky for the development teams. So before doing the project, we went through some research papers on text analysis and text mining. One talked about application review development oriented classifier, which mentioned a process called as RDoc, which had techniques like natural language passing, text analysis, and sentiment analysis that automatically classifies the useful feedbacks and gives it to the developer. The initial data set that we had consisted of 3,439 mobile application reviews from 17 different mobile applications. It consisted of wide different types of attributes like application name, version, user, title, text. After initial assessment, we thought that text is the most important attribute for us with respect to this project, because that will provide us with the data for doing the classification and building a model. Since it was the data consisted of 17 different mobile applications, it had wide range of topics. So you can say that the user will review a particular gaming app very different to what he will give review to a particular app that is used to record videos. So that was one of the challenge, because we had to go more into the details of the application but to some extent that also was some advantage because it provided us with different types of data into which we can train and test the model. Now, since the data was coming directly from the users, we had to perform certain amount of pre-processing. The pre-processing had to be done into, we did pre-processing basically in two different ways. First was the manual one, where we removed the special characters, blank cells, removed the data which was from other language like Spanish. There was a lot of data from Spanish language or German, so we removed that data because we wanted to concentrate more on English. We corrected the spelling mistakes and tried to achieve as much consistency as we can. Since it was like 3000 user data, so we divided it into equal parts, and one person did particular part, then other guy reviewed that particular part. Basically we went through it again and again so that consistency can be found and make sure that all the team members were on same page. So that was the manual pre-processing. The pre-processing which was done on the code included things that we learned in the knowledge processing technology, and we did stop word removal and lemmatization using code. So that took care of our pre-processing part, which was, I think, most essential part, because before building the model, the data had to be properly pre-processed so that training and testing can be done correctly. We created 5 types of labels for this, and that were basically our class. So we had has information giving, has information seeking, has feature request, has bug report, and sentiment score. So has information giving will, if a user text talks about per GUI or something, it will fall into the category of has information giving. If it says about any kind of bug, it will fall into has bug report. The sentiment score will be basically positive and negative or neutral based on the user reviews, and that these all were performed manually by us for all 3000 of the data, or the remaining which was left after pre-processing. The classification approach, we decided to go with naive Bayes because we thought the supervised data algorithm will work best for the kind of data we had. We had limited amount of data, not much, so we thought supervised algorithm will go well. And that we basically, it does is calculate conditional probabilities, and it is used to calculate the probability of particular document if it satisfied a particular label that we created in the CSV file. So to validate the data, we found out the accuracy, precision, recall, and F measure. As you can see, there are some stark differences in the precision of some of the classes here. The reason was that the data distribution was very erratic in some cases. So some had a very high amount of data, like we had enough data for sentiment, but we didn't have that much data for has information given. That's the reason the training and testing didn't work that well, because of limited amount of data, and we had to do we had to reclassify it again and again so that we can get good precision. Conclusion, we found out that after that, based on the data we have, we can perform classification on user reviews to get the exact details of what the development team needs. The semantic and the syntactic structures will make it tougher for classification and text analysis, but by carefully pre-processing the data and properly applying the data model, we can it provided us with a proper success rate for getting new data reviewed and analyzed analyzed by the development team. So with this, the development team will no longer have to wait for a large amount of reviews. Even if there is one particular review, they will get to know exactly what type of data they have and knowledge they want, and can get the best out of the reviews. Future work will try to work this for abbreviations and different kind of languages. Also, there can be a possibility of including multiple type of algorithms, which will improve the efficiency of the model. Finally, I'd like to show you the demo. So for the demo, I would like to show you the application that we developed for this project. It's basically a web-based application for the naive-based classification model that was developed previously, and it uses that model to give out the exact knowledge to the development team of the reviews that they might get in the future for their apps. So here you can basically see we have, this is the home page, and you can see we have text box and get label. So if I write any query here, if the development team writes any query here, they will get exactly what type of information that query is giving out. So if I just write this is basic query, and it's, as you can see, it is not this particular query is not giving any feature details. It is not showing, if it is not asking for any, the user is not asking for inquiries, there is no request by the user, or user is not talking about any particular bugs. He's just telling it is the worst app ever. So the sentiment, obviously you can see here, is negative, but rest all of them are false. If we just want to get, I will just show you the positive sentiment. So if I just write good app, just a basic query, again, not much complex. So here you can see again the user sentiment is positive, rest all of them, like I showed earlier, is false. Sentiment analysis is just the one part of this application. It's not the main part, because main part according to our team was the feature details and the queries and the requests, because that will really help the development team get their application to a better level in on the and satisfy the user, because based on the request that they are getting, they will be able to solve those requests or report those bugs faster. So if I again write, let's say, now if we want to check if the user is talking about particular detail of the app, and I just write GUI is nice. So here you can see application feature details, it's showing as true. So with such type of data, the development team will exactly know, yeah, they are talking about GUI, they are liking our GUI, so we should not change much in our GUI. And again, sentiment is just showing positive because it's just positive. And if I now want to check if there is a query coming like good app but crashes often, so again this shows, that means there is a presence of bug. It is a good app, so it's showing positive reviews, but it's crashing often, so that means there is a presence of bug, and development team will get to know of that. If we go to a more complex queries, let's say we write the app is very well done, simple and straightforward to use. So if I just click on that, you can see it has feature request details, and it is also positive. So yeah, again you can see it's talking about it is simple and straightforward, so which means that user will know that it is simple, so they are liking the simplicity of the app. uh, if there is a game and the user wants more levels, so add more levels, which means user is requesting for something, so it's showing user request as true. If just it is a query like how long for wait, so user has certain queries, and that's the reason the user query is showing true. So yeah, this is the one of the things that can validate that how the classification model, the naive Bayes algorithm that we developed, can be used for such kind of detailed analysis of the text. If I just last one, I add button. Again, the user is telling that you need to add button certain number, some button on that. So yeah, so user request is true, user query is true. Again, goes to show that the how classification algorithm can help you get the knowledge from the text data. The next thing that we came up was using, here we want to try to show you which are the words that keep on appearing for a particular type of label or class. So if we have, what we have done here is calculated a frequency and basically displayed it in the form of a table. So if you see presence of bug, that means there is like game it or update, which means that a particular update has certain bugs. So the development team will get to know that, yeah, if that update has particular, will get to know that which update they will need to work on, so that next time when they bring out certain updates, that certain bugs don't appear. Also, like here you can see Xperia, which is a type of phone, so maybe that particular app was not working on that particular type of phone, or maybe it here it shows again version, which means that that particular app is not working for particular version, or it has bugs in particular version. So again, if we go for user request, it says that it words like videos appear, which means that user requesting certain videos, or maybe the user want certain videos to work in certain type of fashion. So this is the another application that we develop using the classification model, and this is basically the entire application that we developed. Thank you.
Let's talk about the backend of our system. Our backend is made using Python. The steps that were employed while making the system is as follows. First, we loaded our reviews file. After that, we defined our training testing break. So we are using a 70-30 split. 70% of the data will be used for training and 30% of the data will be used for testing. For each of the classes, we build a classifier. Then we test our classifier. So let's talk about how the classifier was built. So the classifier takes in the reviews from the user, and then the reviews are converted into a term document matrix. So from this term document matrix or bag of words model, we further go on to create a TF-IDF matrix using the TF-IDF transformer. After the TF-IDF matrix is created, we fetch this matrix to our naive-based classifier. This naive-based classifier on creation is used for testing the remaining 30% of the data that we have. After we run our system, we see that with each of the classifiers, we have provided the accuracy of the classification, the confusion, the precision, and the error associated with the classifier. Apart from building the classifier, we went on to add another feature to our system. This feature basically talks about the words that affect a particular classifier. For example, reviews has info giving. Taken the reviews that has info giving value equal to true from the manual labeling that we did and finds out words that affect it the most. So when we see the file that was created from this, we see that there are words like application, background. These specify the system features, videos. Let's go on to see what the other files look like. So if we go on to see the info asking that takes in reviews, info asking equal to true. So when we are asking for information, we tend to use words like why, how, what. So we can see that these words have accurately been seen by our classifier. Then let's talk about feature request. So we are asking for features like it will have like screen, button. All these words together specify the reviews that were there in our set. So similarly, the other file was created. So the two important things that we dealt upon was building our classifier, a classifier that classifies the incoming reviews into the classes that are featured, whether the classifier has a feature that the user likes or hates, whether the classifier classifies the reviews into something that the user wants to know about, whether there is a feature request from the user, whether there is a bug report from the user, and whether the user likes the app or not. Next, we go to see which words affect the most for a particular classifier. This also helps in future work that can be done to improve the classification results that were obtained by our classifier. Thank you so much.